we called it EJB hardening.
Yes, it works.
Red paper, exactly, yes. Version 2.1 was very quickly followed by 2.2. I think we never claimed it as a full version. It was more of a technology demo, tech preview, that's the So, Java and Kix ran unchanged for a number of years. But we were aware of some issues. And I'll describe these issues to you. Every transaction you ran used the whole JVM to itself. So we had to have many pools of JVMs to support concurrency of transactions. And if you imagine Kix runs in a 31-bit address space, so you are quite limited on your storage. Storage is the mainframe from memory, if you're not used to the PC. And so this practically meant that when you had 10 to 15 maximum JVMs, you run the risk of running out of storage. So some concurrency were not great. And of course, because Kix was for the mainframe, and the mainframe was for the best thing so you believe, Kix made Java work in a very mainframe way. And we hid some of the internals, or some of the externals even of Java, and created our own APIs to run against Java. And we had Kix options to mirror standard JVM options, and just tried to make it much more familiar to the existing customers that we used to call on the mainframe for all those years, to leave them in general. With hindsight, that was a mistake. These standard JVMs were also stateless. So if you have a pool of JVMs and your application is going to run in one of a number in the pool, you don't know which one it's going to run in. So any transactions that wanted to run Java were stateless or had to be stateless. And you couldn't run the traditional server application type programs in there because your JVM would soon, or may soon vanish. You never knew how long it was going to live for. And of course, debugging for developers didn't like that. Which one of your JVMs has got your plugin in it? Isn't it predominant? So Java didn't really get as much attention as we would have liked. It failed to gain the mainframe programmers' blessing. So it's a bit alien and a bit slow, a bit inefficient compared to Colon. And Java programmers wasn't too.
So having been there at a time, I think it's that way to defend some of what was going on here and explain a little bit further that I guess around that time, Kix had been emphasizing a lot about transaction isolation and the ability of one application to be isolated, one instance of an application, one transaction running one application to be isolated from another. And the way COBOL and PL1 and December allowed one application program or one instance of the application program to interfere with another was our great sort of fear and caused a lot of problems. But when we looked at Java, we sort of extended that mindset to say, oh, we've got to do a lot of transaction isolation because that's the most important thing. That's the root of a lot of the characteristics that we had in this pull model. What we learned over time was that Java programs and Java programmers are a lot different to COBOL programs and COBOL programs. And I must say that I've sort of spent time since this period sort of unwinding a lot of the protections that we put in that turned out to be either merely redundant or actively unhelpful. But now that I guess we're going to talk about how we've taken the plunge.
Java is supposed to be fully encapsulated.
Well,
does it work like that?
Yes and no. I mean, Jeff, I'll probably talk to Jeff about the way that when we were doing each transaction of JVM to itself, that does very good isolation. And we went through several stages of engineering with the IBM JVM team schemes where the memory management would be sort of somewhat transaction orientated. You can end one transaction and clear the memory very quickly, so that one transaction wouldn't infect the next one. But then that caused us all sorts of hassles with heap references that were some from the system code into the application code, and half the memory got cleared and half of it didn't. So encapsulation was good, and garbage collection, again, was pretending that the application people didn't have to worry about memory because it was all garbage collected. I'm sure we've all got experiences of how that doesn't eliminate the occurrence of memory leaks, for example. It just makes them probably hard to work out what is actually leaked. But the basic point being that, yes, the way you write a Java program is a lot different to the way that people have written and continue to write COBOL programs. But that meant we, after some experience, which we had to gain, we realised that JVM is actually a pretty good environment to just let run in its right terms, or as nature intended, and not as CICS imposed as something that work.
I should probably apologise for some of my dirty graphics at this point. There are more. So, one day I was in my office reading the other cartoons as you do, and my piece was disturbed by a couple of my learned colleagues excitedly coming in and saying, "What if we just ran Java like it's intended to be run?" That's something like, well, we could have a multi-threaded JVM. We could run more than one transaction in the same JVM. We want to still leverage all of that legacy data and still link it to those core applications. So, of course, I was left with no idea what my next assignment was going to be. And there were many challenges. And I may get a little too low level technical here. Please stop me if I do, or if you've lost me completely. But one of the things that we encountered was that Java runs in this kind of a POSIX environment on the mainframe. We call it LE, language environment, and it's only got a single entry point. So these transactions that normally flow and use the whole JVM, there were some good reasons. One of those reasons is that that thread that was running that transaction in CICS could only get in using a single entry point. So you couldn't have more than one. But this was one of the challenges I had to solve. And if we could get lots of these transactions in, then how does the JVM share the shared state or the context of these CICS tasks and transactions that are running? And again, if there are multiple POSIX threads, we'll call them, that run in the JVM, how would the CICS dispatcher maintain control of them? I mean, they're in a different environment here. It may be the same address space, but it's very foreign technology to address.
So when Ivan said earlier that we distinguish applications from, say, the operating system or database, in a different world, you would just let the operating system provide threads and provide processes and assign processes to the processables, to the cores that you've got available in the machine. But one of the things about CICS since the beginning was that, and I was talking to Ivan on the train on the way out, what CICS did with our old green screen terminals, because remember, 1969, it was all green screen text terminals connecting into a mainframe. And it was engineered at that point in time to manage efficiently a lot of terminals that the operating system by itself couldn't do by using one of these TCVs in a single. But it's a single thread, but the CICS dispatcher that we mentioned there is doing its own context switching and dispatching and all that sort of stuff. That's in fact very similar to systems like Node.js that are emerging at the moment. If you go and look at what Node does for JavaScript, it handles a lot of web sessions, but essentially on a single operating system thread, because that's how JavaScript works. You can scale to have a greater number of interactive sessions without using up quite so many operating system resources if you play the trick of taking a thread and then sub-dispatching it. But Java has a very mature and comprehensive threading model. So part of the challenge that we had was, rather than use it in a very restricted way that we had been doing by putting a single transaction into an entire JVM at a time, and then serially reusing the JVM over time, we actually wanted to run the JVM, as I say, as nature intended, with individual CICS transactions using the actual threads that the JVM is looking after. And they, in fact, map down to, quote, ordinary operating system threads, and then get dispatched onto the hardware. So we had to marry the world of CICS, where we've got this particular environment of sub-dispatching, with this full-blown thread, full concurrency model that the JVM, as nature intended, we deployed. So we had to rethink the way in which we move the context of the transaction on and off the execution units. And I think I'll maybe let Ivan talk about that, because some of us don't actually understand what was done.
Can I come in the world of sort of committing rolling back the database and file system?
Right, yes.
Somewhere outside.
Indeed, we are. Yes, so that's actually another point. I will talk about that considering you bring it up. When we mentioned EJBs, for example, one of the big challenges was to marry the non-CICS view of a transaction with the CICS view of a transaction. CICS is just 100% transactional at its heart, whereas the view in the Java world is that, well, you might have a transaction there, and sometimes you're in a transaction context, and sometimes you aren't. But you can start one and suspend it and then go back to it, which we don't really do, like, but we have to marry that world together. So one of the challenges with EJB, always comes up with EJB, is the declarative model of being in a transaction or not, having what WebSphere terms local transactions, versus the transaction model that CICS has, where you are always in a transaction. If you commit one, you're immediately in the next one. So yeah, that is a sort of point where the two worlds do butt up against one another.
Well, continuing on that, I think also comment on which way through transactions they go.
Right. So what we've done with the JVM and with Liberty in general is that CICS has always supported, CICS for a very, very long time has supported the idea of a global two-phase transaction, particularly between what you might regard as the application and what you might regard as the database, where the database is separate from DB2 or layer, for example. So that's normally how we would two-phase commit. CICS manages some resources itself, so there's a file system called vSAN, and there's key sequence data sets like there, and CICS is essentially the transaction manager for those things. And we have a component called the recovery manager that deals with all that two-phase commit protocol. Now, something that we've done recently, and we'll talk about it at some point, is that Liberty, this WebSphere application server, we take the entire system and we run it inside CICS. We've had to marry the idea of the WebSphere transaction, the Java JTA transaction, with the CICS unit work. So we played this trick a couple of times. Essentially, we just make sure that one enlists with the other, and we get the transaction integrity that way. We have to pick either one transaction or the other, sort of local transaction, to be the coordinator, the initiator of the sync point, and then we just use normal two-phase commit protocols, even within the same task, to coordinate all the underlying resources. So it has been a bit of a trick for us, but it's just a fairly obvious extension of how transactions work when you've got multiple systems. They just happen to be resident on one task.
I think you use the word distributed. Yeah. So you carry the two network.
Oh yeah, I mean,
You always think carefully before you do.
Absolutely, mainly from the locking point of view rather than then get onto the overheads and the screws.
So the final challenge on this slide was the fact that we have two different executions. It's CICS kernel itself maintains an execution, and the LE POSIX side of the system and JVM runs also two executions. We wanted to be able to run essentially in and out of two environments on the same TCB. TCB is a task control block, I should say, which is a thing thread. It's the operating system thread. And at the same time, as we've just been discussing, of course, is we have to maintain the robust recovery that we're used to. This is the difficult bit. This is how I have to try and describe some of the things we did. Yes.
You know,
So with our previous experience with the old JVM model, the old way of running Java is that JVM would be created on the initial process thread. And that's if there's no concept, if you know, POSIX is defined. And this is created within the CICS address space. We can actually use that initial process thread to create JVM. So it uses JNI, Java Native Interface, to JVM. But once it's created the JVM, it has a second purpose. We actually put it into an NVS word loop at this point.
what's MBS?
NVS. Have we not mentioned NVS?
I think
That's the
so.
same word as System Z. Name for it. It's actually the operating system. Actually, it's not called NVS anymore, is it? ZOS, I should update my terminology. They're essentially the same. And we came up with this concept that when CICS dispatcher needs a new Java-enabled TCB, remember these TCBs, or these threads are known as TCBs when they're in the CICS environment, it could send some form of communication across to the community that's running positively. And that communication is a well-known technique and for an NDS PCB, so it's for event control block. And that wakes up the LPT, which was in this kind of sleep. And it knows when it wakes up, I should create a new thread. And this is how we got around that single entry point. So instead of having lots of TCBs or threads go into the JVM environment, we had the one that were allowed in, and then that will spawn the others that could be made available outside.
Is that the start of the session? That coincide with the start of the session, would you say you need a new Java enabled task?
Yes, so it will be the CICS transaction or session that wants to run some Java, but this little mechanism is in the middle is agnostic of the session at this point.
Any time in the life of a transaction, because we had to work. The multi-language is not just that we can run transactions that are either in PL1 or COBOL or Java, but a single transaction can be made out of a component in COBOL and then can essentially pass control to a Java method, and that can be a time when it's got that.
Thank you.
So this newly spawned thread is just a standard POSIX thread. Doesn't know anything about CICS at this point. So again, we use some native code. We bootstrap up this thread through the CICS kernel. And we do it as a CICS capable thread. And that puts some environment on the TCB to allow it to run in CICS and have these CICS capabilities. And once it's come up through the kernel, it's given to dispatcher, CICS dispatcher, which puts it into a pool of what's called T8 TCBs. And that's the name we gave for them, T for threaded. 8 is the mode of TCB. I'll try not to get too much into that, but 9 is a user mode, 8 is more of a system mode, so it has more visibility of storage.
Like memory protection.
Memory protection. Yeah. And so it becomes one of these T8 threads or TCVs. It has the CICS environment established on it, and it sits and waits in CICS Dispatcher. And it's one of these that Dispatcher gives the transaction that wants some Java. So it says, right, well, here you go. Here's a Java-enabled thread. Now run your Java code. And when it does that, I should also say it takes the transaction state and environment and places it onto that TA TCP to give it the context in which to run the transaction context. And this is the fun bit. This is how we got around the stack execution problem. And a colleague who has since retired, he's responsible for this bit of magic. He noted that there's a special machine stack in the COS hardware that allows you to kind of stop or hold your stack, save it somewhere, and start executing another stack elsewhere. And you can use this special stack using PC and PR instructions, which are COS assembly instructions. And so it allowed us to go from CICS world running as a TCP to essentially jump into POSIX world and run as a Java thread. But remember, we've already put all the CICS state on that TCP, the state goes with it backwards and forwards. And from there, it was a simple case of using JNI, which is Java native code, and being able to attach that POSIX thread as a Java thread to the JVM. And then you run the Java class or whatever code it is that the transaction wanted to target. Actually, there is another point there I should have mentioned. When it comes to having multiple threads and multiple transactions running in the same JVM, that task context is all stored as some thread local. I don't know whether you're familiar with the concept of thread locals, but in Java it means that for the lifetime of this thread, you can associate pieces of information with it, and although the Java class will have a variable that all the threads will go through, each thread gets its own copy of that variable in Java. So it separates out the task context for us. And then on return, Java's done whatever you've asked it to do. Perhaps you've even linked to some COBOL programs off of that. But we can provide the return values and the traditional CICS COM area. Familiar with that, so we're passing back the data from the application or from Java back into CICS COBOL application for the time. I've moved the thing over there, the SJK, that's our controller, and that's the way that we pass some of this information across. And the reason we can do that is because it's a piece of storage that we hang off of the task controller, the TCP. It's a little piece of stuff we add onto the thread that goes with it, wherever the thread executes. Of course, once that particular Java program is run and completed, that TA TCP has finished its Java work and it's put back into the CICS Dispatcher pool TCPs and disassociated from the CICS task that we're running with. And in that way, we don't have to have the inefficiency of using that spawning mechanism and dubbing the CICS TCP as CICS capable every time. They're already CICS capable, but they're cool and we can use that for efficiency. And this is just us stirring up the folder and ingredients to eventually get us this CICS capable Java code that runs in a multi-threaded server JVM. That leads nicely, and we used our true imagination, I think, with the name. We came up with this new CICS resource, and we called it the JVM server. So, yes, we must have been short of inspiration. Yeah. But it gets the concept across. Where previously Java was kind of a one-shot deal with CICS, it's now a full server and a long running server, so you can stay there and maintain a state. So each CICS task, as you can see, can run as a thread within the JVM. And each CICS task has access to the JCICS API, so that is all of the exec CICS commands that we're so used to or customers are used to using with COBOL. So you can get at your CICS resources and you can get at your CICS data. We also extended the JVM and the enclave in which it runs to do 64-bit. And that was a great advantage because you can get lots and lots of JVMs running within the address space now. We did want to maintain that concept of having multiple JVMs in the same address space. So although you can run lots of threads in each JVM, you can also run lots of JVMs as well.
What sort of numbers are we talking about?
We picked a number of how many threads we would sort of happily put into a JVM at 255. Just sort of.
Six. You picked a number as well.
No, I thought we subtracted one for some reason.
But one was a system thread. Yes, we
Yes.
observed well.
Yeah. Just because we were being fairly conservative in the beginning. And of course, then you can, now we're 64-bit, and then you can JVM. We're not nearly as memory constrained as we used to be. So we can think of having maybe tens, hundreds of JVMs active in one address space. CICS is traditionally scaled by both sort of what we might call vertical scaling within an address space and then horizontal scaling by sampling out more circuits and dealing with it like that. So CICS can scale in either dimension. Really now we've got support for this threading to use more resource in a single address space, and a 64-bit address space. But equally, for resilience, people will stand up multiple servers and distribute the work amongst those multiple servers. So a point that I like to make about what we've done with JVM server is where before it was very constrained compared to the COBOL environment. The COBOL environment was always going to run hundreds of tasks concurrently, and JVM server, JVM pool couldn't. Java essentially scales the same way as COBOL ever did. And one of the nice things about JVM with its JIT compiler is that you write code in Java, and then as IBM upgrades the machines and puts extra efficiencies into the instruction set, then the Java applications take advantage of those extra instructions as soon as they find themselves on that machine. So you might be asking the question, why have we gone to all this maximum way of exploiting machines? And also we were addressing the skills. I've said 950,000 COBOL programmers or CICS programmers. Well, yeah, but they're all at a certain age, or tend to be at a certain age. And Java folks tend to be at a different certain age. Node.js programmers will be at a different age. So that's why we have to keep up with the technology and run it as efficiently as people are used to with assembler or COBOL. That's the challenge we set ourselves. We have to evolve over time with different ways of exploiting JVM or other runtimes within the CICS environment.
The test team ran with 100 plus JVMs in the same CICS region.
Now you've got application data may be shared. I'm not quite sure of how that works, but to what extent is that transactional? With tasks going, what's going on there?
So in this context, I think application data, I'm referring to Java static variables, class level, or Java objects that encapsulate data that can stay live in the JVM, even though that particular session has come and gone again. Perhaps it's left, altered some state, and left it there for other sessions to come in.
That was one of the real learning points between the pool model and our focus on isolation. Everybody wants isolation, don't they?
Yes.
And the way Java programs work. Because one man's isolation is another man's, I can't build a cache.
Yes.
And that was sort of one of the learning points that said, you've got to let them get on and maybe hang some data in static and actually have multiple transactions potentially get hold of them.
So they've got to do their own undos or something.
Well, but this isn't really for business data as such. It's not stuff that's going to be hardened to a database. This is working storage almost. But if you've gone to the expense of creating a database connection, for example, you want to share that amongst different tasks.
Thank you.
So, one of the things that might strike you here is that I've said there's no EJB or code support. And yet you just heard Ian talking about our EJB and code support.
But I wasn't that enthusiastic about it, though, was I?
No, no. But this is a statement of the base JVM server. It's not a statement about technology as you'll see in the presentation. But at the time, they got burnt a little with EJBs. You might say customers didn't react to what's in that time? I'll try and explain as well. So, progressing the slides, debugging is much easier because it's obvious with JVM you want to debug it. Types or utility clips or wherever you debug it. We configure the JVM in a very standard way, something called the JVM profile, which just has the Java options to pass straight through to the JVM itself. There's another aspect of configuration, which is something called an LE runtime options file. That's about tuning the POSIX environment that it runs in. We provided an out-of-the-box kind of best can do option for all customers that don't want to compile or tune to the nth degree. So a set of options that work for most people. And of course we provide statistics, just like all CICS resources, which can tell you all the information about your JVM server, how many threads are currently running, how many threads have run, how many threads have, or how many transactions that have to wait because there weren't enough threads available, things like that. And the underlying JVM statistics like your heap size, which garbage collection policy you're using, how long your CPU is spent doing garbage collection, those types of things. So in 2009, Ian's mentioned this dynamic scripting feature pack, or SMASH, or PHP, whatever you want to call it. This was released in CICS TS version 4.1, and the underlying infrastructure was a JVM server. And in CICS TS version 4.2, we then gave full announcements of the JVM server resource and allowed customers to run their Java in a JVM server. We announced at the same time that the pool model, the old way of doing it, was to be deprecated. The advantages of the new JVM server, we've probably covered them. So skim through these, you get all the scalability, the robustness, centralized admin control of running Java on the mainframe. You can legacy all your, you can leverage all your legacy applications and your data. You can link to kernel programs. It's all fully integrated with CICS, so you get mainframe security and the CICS transactions that everyone's so used to. We gained a significant storage reduction because where we used to use, well, let's say, you're running all 256 threads concurrently, that's 256 JVMs, which takes up a lot of storage. Now we just use the one, so there's efficiencies to be gained. And of course, moving to the 64-bit JVM helps because you can have massive JVM heaps as well. This is something we always get asked, isn't it? Why would you run Java on the mainframe? Well, we try to give people reasons why they can run. What are the reasons? We've got this concept of consolidation of servers. One mainframe, one guy to administrate it instead of maybe a server farm. So more efficient, we've got robustness and scalability and security. And then this center of gravity term. That's about if all of your CICS data, or all of your data is in CICS, and it's has many programs with lots of business logic, and they're all in CICS, and you want to add a new interface or a new extension to the application, then really the most efficient place to put a new application is in CICS. Zips.
Don't talk about that.
A cheaper way to run Java. Yes. This was a surprising one. Some customers actually moved to using Java or putting new applications on Java on the mainframe because they had spare capacity. And rather than commissioning a new distributed server, they could just run it when they already have the hardware. It cost them anything more. So, moving on a bit forward in time, some issues with Java. So we thought we were quite pleased with ourselves that we changed the architecture and it was working so much better. But then it came to our attention that Java isn't so great. And it starts with a jar file. It's a packaging component where you put class files of a compiled Java application. But it doesn't have any of this modularization. There's no way that you can scope jar files. There's no way you can declare dependencies between jar files. It doesn't give you any versioning, so you can version your code. And there's no indication of what interfaces you might consume or what interfaces you would implement. So it's a bit of a black box, really. And the good old class path. In enterprise applications, we typically see with our customers where they have just about every application under the sun running in their chain. They have a huge amount of jars on that. And sometimes they might forget to put one of their essential jars in. They won't find that out until runtime. When the class path is scanned, it's not found, and you get this dreaded class not found exception. And again, if you want to update your code on the fly, you can't, or not very easily, I should say. You have to restart the JVM for it to pick up whatever new jars or new code you put on the class path. So it's not particularly dynamic or flexible. This one's a bit kick specific. We never gave Java programmers a hope of getting into the mainframe club. We made it very difficult. There were no tools available. You run your own. You use FTP, you use Unix system services, and you didn't get any of the benefits of the modern tools. So we wanted to try and address that. So we came up with some goals. I've kind of given again away a bit here with the title OSGI, so if you're familiar with that, you know what's coming. Again, you get the idea of minding my own business in the office when I get this delegates and colleagues come in here and friends with some new wonderful ideas. This one, we've gathered an OSGI expert for this one, who came to tell me about the virtues of OSGI. For those not familiar, OSGI is a modular system and service platform for the Java programming language. It implements a dynamic component model, which allows you to install and update applications on the fly without having to restart the JVM. So it's quite useful. And it introduces the concept of an OSGI bundle. And a bundle is a way to package things, just like a jar file. In fact, it is a jar file. The only difference is that you add some manifest entries, or some headers, as you can see here, into the manifest file. And these are what define the characteristics of OSGI. There's one mandatory header, which is the symbolic name. That's kind of like the identity, who am I. The rest are optional, but rather useful. This one says exactly what package or what code that this jar or bundle will export for others to use. It tells you what's in it. This one tells you all the things that it depends on. So this won't run unless in the same system you've got these other things as well. So it's a great way of being very explicit about dependencies. So it's programmers thinking more about how to structure their code. And OSGI does away with the class path. Instead, each bundle has its own class loader, and you load the minimum set of Java classes onto that class loader as possible. So you can see each bundle has its own packages. And then there's this concept of a class space. And the class space is all of the classes that that bundle can see. In this case, you can see these packages that have been exported from these bundles and imported by this one. And what OSGI does is it says, well, I'm going to give you a mapping of how to get to those other bundles. And those are the class loaders for when you need those classes. This is the OSGI bundle lifecycle. And unlike normal Java, you don't just run OSGI. You have to do some prep work she was there. That prep work is to install the bundles into the system so they're all ready and available. And each bundle goes through this kind of a life cycle. And when you first install the bundle, it's in this install state, and it will only ever be resolved when the dependencies that you've been explicit about exist in the system. So you know when it reaches the resolve state, everything's there, and then you can start the bundle. There's an activator you can optionally run at this point to do some initialization, and then the bundle's active. And that should mean that at runtime you can call the interfaces that bundle supplies without failing or without having the dreaded class malfunction. So it's a really good way of forcing structured programming, and it calls in interfaces to be explicit and much more defined than the other way before. So we took this into CICS, into our JVM server, and we had some goals here. We wanted to provide the same Java as before, but you would just repackage it in an OSGI way and be able to deploy it into CICS. We wanted to allow the recycle, so that this is the life cycle of applications to be controlled and allow you to update your code perhaps, or stop your code without having to stop the whole journey. So only that portion or only that one application is affected. We wanted to have multiple versions of an application running in the same system at the same time. And OSGI gave us these things. The other one, of course, was about us creating some nice, useful tooling for Java developers. So you'll see that what we did is we took Eclipse and we added into it an extension, plugin, and it allowed you to do communicate with the mainframe, develop in Java just as you ever would, and then use some automation just to push your control up to the mainframe. So it's okay, some hassles. We got there by embedding the Equinox OSGI framework in the JVM server. Equinox is the reference version of OSGI. We also did some work in CICS to extend some of the existing resources. And this is a bit unfortunate, but there's this notion of a CICS bundle. And it's not an OSGI bundle. And most people get confused. But CICS bundles came along before we were aware of OSGI bundles. It's a classic terminology. But we actually use CICS bundles to contain one or more OSGI bundles. And it's the CICS bundle that gives us that ability to install, enable, disable, discard, and control the lifecycle. So Java applications in CICS now have to be written and deployed as OSGI bundles. I've mentioned the tooling updates that we made, and the way that it pushes up your deployed bundles to the filing system for the mainframe. As before, give it a whirl. We've got this OSGI-enabled JVM server, and that gives us all the things we wanted. Dynamic updates, multiple concurrent versions of an application, dependency resolutions, so you get these runtime failures, and of course these defined interfaces, which forces your developers to write in a much more modular fashion. So, last 5 minutes. So you can follow again. WebSphere application server, WebSphere application server is IBM's Java application server. It's JEE compliant, and again, that's not been many years of running these, but it was a bit of a sprawl, wasn't it?
Yes, so on ZOS, WebSphere had a unique implementation. There was not your run-of-the-mill application server, just like CICS isn't really your run-of-the-mill application server either. But using some of the particular features of the operating system and the Z platform, WebSphere was engineered to sort of be a bit like CICS, but use sort of in a JE sort of style, so there's multiple address spaces and they do workload management and all that sort of stuff. But it means that the application server itself is there's quite a lump of stuff. Not valuable, but quite a big lump of stuff, and it has to go into how it's deployed. So we could never really think of taking advantage of components from WebSphere and running them in CICS. But after WebSphere has been around about 12 years, 15 years, whatever it is, much like when CICS was around, and CICS has been around for 12 years, 15 years, or whatever, they said to themselves, oh, we can't go on like this. We need to take a fresh look at the architecture and componentize it. CICS went through this at about the same stage. That's how we got to the back this. And so WebSphere have done the same. What we ended up with was a much more modular system. So CICS became much more modular in about 19, when did we do 3.1 come out originally? 89 or so. Something like 89, yeah. So we took about, well, I can't say we just started, but the project took about 7 or 8 years to come to fruition. Things move a lot faster these days, so I think WebSphere probably took about 7 or 8 months to create a Liberty profile. But it essentially meant that we had a set of Java components that would run in an OSGI multi-threaded environment. So we said to ourselves, aha, well, that's all right, thank you very much. Ivan, how do you fancy?
How that's like, you know,
I thought you were right. So the Liberty profile. So when you buy the WebSphere today, and if you buy WebSphere on the COS platform, you can run what we term TWAS, traditional WebSphere, with the shape that it's been for the last 12 years. Or you can run the Liberty profile, which is a single process server. As part of the objectives for as well as restructuring it to make it more modular, was to make it that much faster. So application developers don't want to, all that same, lightweight, composable, fast. But importantly, it was designed from the very beginning to be embeddable. We're not doing anything that's unnatural. Liberty was designed to do the sort of thing that we then said, we'll take that and we'll embed Liberty inside CICS. So we talked about how we've taken the JVM and run it in CICS, how we've taken OSGI and run that in the JVM, well now we take Liberty and run that in there as well. So that was the breakthrough to get an application server implemented in a way that was embeddable in different environments.
And to give you an example of some of the things that are like this Liberty profile, Lastfish and JBoss and Jetty, those kind of web application servers or JE servers, those are the equivalent to the Liberty profile. So I think we can describe this quite nicely. That's what we call traditional WebSphere, one big lump of stuff that you can pull anything out from. And this is Liberty, which is much more composable architecture. And you can choose how it looks. You can choose the components in any server instance to keep it lightweight and specific to the needs of your applications. And it's vastly simple to configure. In fact, it's configured or it defaults everything out of the box. And we use this configuration by exception. So everything should just work, but if you want to change something, then you may do it through this description file, this configuration file. And it's the only configuration file for Liberty, which is a refreshing change from big WebSphere. So this particular example says I'd like to run this web application and give it the capabilities so it's ready. There are some caveats. It is still a subset of the full VARS capabilities, but it is JE6 web profile compliant. And as Ian pointed out, it's written in Java, it runs within an OSGI framework. These typically are the APIs that you will get as part of the Liberty support, JEI, Java transactions, databases, JVC, systems architecture, Java messaging, and EJB Lite. So, like I said, we didn't run EJBs earlier. Well, now you can see why we then maybe have to come back in again in a different form. And there are other routes to get
I'm not your father,
Exactly. much improved, much simpler. A number of interfaces for getting into the server, JSON and JAX-RS, the RESTful APIs, and JAX-WS web services. So it'll give us some enhanced capabilities that we can in case. So it should be a plain server, shouldn't it, Ian, just to drop it in?
Yeah, that's what I told you.
Yeah, you did. Thank you for that. But it never turns out that way, does it? So we had some challenges here as well. And before we got to the light at the end of the tunnel, we discovered that it's not written entirely as OSGI bundles, because it consists of a JVM launcher as well, and some OSGI bootstrap code, and some pre-OSGI class loaded logic, which was just enough to separate the class loaders to give us a lot of headings. But we did bypass these challenges, bypass these issues. We got around the JVM launcher so that we could create an instance of Liberty within our own JVM. We added some bootstrapping with the OSGI framework ourselves to get it to the same state as it would be if it was Liberty's. And we took advantage of some extension points of Liberty. There was this product extension. The CICS became a product extension of Liberty, which was kind of embedding some CICS code in Liberty to be able to embed Liberty in CICS. Strange, but there you go. Internally, we called it Trojan, because we got our code into take control. Skip over that. The other big challenge is that requests and workload comes in to Liberty, and it comes in through a native, what we call a native NVS IP stack, which goes into Java sockets directly. And that's not usual for CICS. CICS has its own TCP/IP handling, and it usually comes into CICS through the front door. This would come in through the back door. And CICS wouldn't know about it. And because CICS doesn't know about it, it's not on one of those nice T8 threads. It's on a non-CICS enabled thread. And so that means you haven't got access to JCICS. There's no CICS data available. You can't link to your COBOL programs. There wouldn't be much point of running it inside the CICS under those circumstances. So we had to do something about that. One of the benefits of the way Liberty was architected was to use the Java comparison language. And that enables you to submit work to a central agent, and that central agent will then decide which threads is going to put that work onto, rather than the older way of doing threads in Java, which was just to create a new thread and run on it. This gives kind of an intermediate way of doing things. And that was good for us because we could override the default one and replace it with a CICS one that created as a CICS thread. And then we had to do some enhancements and use the ECV communication mechanism I mentioned earlier. So this time we're calling from Java to prod CICS to get CICS to create a new transaction, which prompts the POSIX environment to give us a new thread, which we can then run as the thread on which the requests run. So these are HTTP requests coming to Liberty as web applications.
I just want to general
So how much more have we got?
We get to also a couple of slides in this.
Okay. Okay.
I'll skip over the internal issues of fixed packs and so on. Security integration. It's sufficient to say we just integrated it with COS security, so instead of using the Java distributed model, it's using full stack or games within it. And we could push the identity that was acquired from the through into CICS so that you run your CICS transaction under the same user ID as you run your Java side of things to integrate it. So we embedded the Liberty server. Use the product extension to inject the CICS code, we replaced the executive service to give us CICS threads. We used enhanced bundles even further, so we can now have web applications controlled by the CICS bundle as well as the OSGI bundles and applications. Security. We enhanced the tooling again, so that if you're familiar with Eclipse and creating files and files and all of those web artifacts, then you can do that in our environment. And again, We've come up with to run this very fast, lightweight server locally in the same address space to handle all of this web traffic directly in here and integrate with all of these resources. I'll skip over this. This is just details of the various web applications, EJVs, EAs and ROMs and EBAs. So really, we get into the end, a summary here of what this has given us for CICS and Java mainframe. It means we can run all of the front end things, presentation layer of things, and CICS as well as the business logic that we traditionally expect to see that. We can support all of this newfangled stuff, JSF, JSPs and stuff. And we can give Java applications direct local access to all of this CICS data. And mentioned JavaScript and JSON, great for lightweight access. We can straight to CICS data using those interfaces. Web services to expose the traditional CICS web services, but this time through Java. We did support it through CICS native web services. So now there's a Java there as well. Yeah, this is just a final diagram to show how you put it together. You develop your applications in Eclipse using some CICS Explorer as an enhancement to it, and use the export wizard to push your Java code up onto the mainframe. Here's CICS, which wraps it up in a CICS bundle to control the lifecycle, deploys it into this Liberty server running in our journey. So this is configured by the server XML I showed you earlier. You can see that you can call presentation logic with, well, it's not really back-end, but it's more business logic, which itself can call out to all the CICS resources. And we get there, we've got a request coming in. This gives us the ability to put different web requests onto different CICS transactions so that we can classify the workload, some of it's accounting, some of it's and we get the added layer of CICS security on top of it. Eventually, you see we can call the backend CICS data and CICS resources from this web application. This is still running at server with full access to CICS.
So if we circle back around to the beginning, where we said we made a bit fuss about the fact that it's it's an enterprise class, multi-language application server. I don't think we find it. The challenges we set ourselves were the traditional, in some ways, the traditional. Introduce COBOL, high-level languages, C, C++, and then Java. Because lots of other people, both on the mainframe and not on the mainframe, distributed with products that have tried to marry the different language environments together. And you always get complications when you go from one language environment to another. But it just seems that what we've managed to do, solving some of these problems, is produce threads that are these hybrid threads with many different personalities. We've got a colleague who talks about them. It's like those optical illusions where it's either a vase or two faces looking at each other, or it's a duck and a rabbit. Because depending on sort of which way you look at it, it's either it is Liberty and it is a server engine. You put it the other way, and it's a transaction system, and it's CICS running COBOL, and it's all this sort of mysterious hybrid thing. But the value is that all the application assets that people have had for umpty years can now be extended and used very, very efficiently by any number of services on the front end. So we use this, except this is in fact for moving into areas like mobile. So we've got customers who are they're getting very worried because they're running so much mobile workload, making service requests to their CICS applications that, well, it's really expensive, but they're getting a lot of value out of it. But it really is just saying that what I'm the team have managed to do in creating these hybrid environments is of great value to the applications. Well, the applications are able to deploy this stuff, the enterprises can run this stuff, and it continues to be successful.
That's great. Now, let's see if we have any questions. None at all.
have come along the way.
I'm sure there are questions. So, I'm going to ask a question. The question is, can you give us the example of an application that's actually used for such stuff? Don't name,
yes.
Don't name the company, but just tell us what sort of an application.
Yes, right, yeah. I mean, you've got a pet customer, haven't you? So, is there an example there? That,
Probably not really into detail, other than they are using it.
tax, but not in this country.
Yes.
All right, so
So it's a government.
but we've got that.
Government
So
application.
we've got there's companies, there's a particular customer in Europe who is re-engineering their system so that they can reuse their COBOL logic, but extend it with a set of servers. So whatever the business systems that they've had for years and years and years are now being enabled for web and mobile. We've done what we call a feature pack around mobile, which uses some of the JVM server technology. And I heard today that by looking at through our service organisation, they're now running 3 million transactions a day that come from mobile devices, come up as an HTTP request, go through the JVM server, but get essentially to the same applications and data that's been running the business for 20 odd years. So it is any and everything. There's no particular industry alignment or geographic alignment. Well, it must be said that there's probably more success in Europe than there is in North America. And I think North America took cool JVM and sort of it smells a bit bad, and we have to convince them to go back to this. So, but it is a lot of focus on upgrading specifically to get this benefit. I think it's general. I can't tell you go and talk. Go and use this app on your mobile phone and it's bound to be using this. I can't tell you that.
Any more questions? Okay.
No, there we go.
Oh, I was just wondering, how do you handle live debugging something 3 million transactions a day? So,
Right, yes. Well, one of the things here is from the CICS angle, when you're looking at it like it's two faces facing each other, then all the usual techniques apply. So CICS and COS have numerous ways of taking traces, dumps, attaching debug sessions. When you look at it from the other angle, and it's vars, the standardization of the JVM means you can attach the standard Java debuggers to it. So, I mean, in production, when you're running 3 million, it obviously gets a bit harder. But if you're in the application development scenario, then you use all the standard tools. Obviously, we cope with people sending us in diagnostics from production scenarios, but essentially, because of the way we've integrated it, it's business as usual. When it comes to, you do have to, JVM and Liberty do write their own sort of log messages and all that sort of stuff, which we're trying to integrate more closely with where CICS system programming to go and look at it. That is a sort of hygiene factor that we're addressing at the moment. But it's sort of, generally speaking, business as usual. In terms of diagnostics.
Go ahead.
Well, just as a general question, you mentioned where at some point the variety of languages and where you would, it might be used for different age groups or other groups. So the communities are in comments on what's sort of the new raft of JVM languages, Scala.
Right, yeah, indeed. So that's a very good point. I like you raising that point because on one of the CICS community forums, we turned out to be one of our business partners, started asking questions because he was implementing Lua. So I don't know if anybody's heard of Lua, it's been around, scripting language has been around quite a long time, it comes out of Brazil, I think it is. And that made me think, oh, right, if somebody else has had it, I'll know about that. So, in fact, that meant that a couple of us raced each other almost to sort of download the Scala compiler, convert some of our sample code that's in Java across into Scala, which is a challenge. But yeah, so we run Scala in the JVM. There's a little bit of jiggery-pokery around how it got launched, which meant I had to write a Java wrapper of Scala because we expect a static void with Scala was producing a slightly different method signature than the one that we were expecting. But I just wrapped it in a thin Java wrapper and then invoked Scala. What Scala claims in terms of bytecode compatibility was fine. JVM couldn't tell that it's Scala, really. I'll say that IBM is looking at things like JavaScript, Node.js. Just on Linux for System Z, we, I think about a month, 6 weeks ago, we made available a port of Node.js onto Linux on System Z. So it's might be sort of next on the list. I don't know.
I'm going to try and just sort of put forward to you a sort of very general idea of what's going on here. See if you think this is right. In CICS, in the normal process, the identity of the process is bound sort of implicit because it doesn't then want to stack pointer as to what your identity is. But in CICS, it's different because you've reified, you've made it explicit, a whole block of data and a whole lot of things hanging off it, a whole lot of stuff that makes it that task. So you've been sort of taking away the implicit nature from some of the stuff that's going on. And by doing that, by reifying it and making it explicit, you get it much easier to manipulate this identity and to use multiple identities because you think it's a bit like putting a stack in the heap. Instead of stack frames in the heap, you can play about more than using a hardware stack. So, and I think that sort of explains what's going on, how you sort of cope with all this complexity, is the fact that it's a bit like when people say we can do anything by an extra level in direction. You know,
One of my favourite phrases.
Right, well, in this case, you've sort of got an
Every
extra
problem
level
in computer science that can't be solved.
of making it explicit. You've got an extra level of making it explicit. So by making all one thing explicit, manipulable, first class in a way.
Yeah.
So then you've been able to do all these complicated things
But
and manage them.
yeah, I think you're absolutely right. And the challenge and the bit of magic that Ivan referred to was one of the techniques of getting that explicit state injected onto a new environment. And like I say, some people understand it, some people don't, in terms of what actually goes on in terms of the magic. Yes, indeed. But yes, you're right. By virtue of making a very explicit set state, we can, so long as we can move that around, and it is a challenge to move that around, we have to find, as well as doing that stack thing, we actually have to discover the Java JNI call that said take a non-Java thread and attach it to the JVM. That's sort of another piece of the mechanism. But JVM had that as part of its architecture. We just discovered it.
Right, I think we'll stop the questions there. We've got a buffet and some wine after some plenty time to talk. Okay. So let's thank Ian and Ivan for coming on tonight. This is a very interesting talk. And if you'll excuse me just for one moment, if you'd like to unhook your machine, I'll bring my machine up and we'll just do the AGM.
How long is